The topic of this problem is Kirchhoff's voltage law. And what we're going to do in this problem is we're going to write the mesh equation, or also known as the loop equation, for this single loop circuit. Additionally, we're going to solve for the voltage from node A to node E, and also from node E to node C. And so we'll see what these voltages come out to be as we add up the voltage drops across various elements. So the first thing we want to do is write the mesh equation. So if we do that, starting at the lower left-hand corner, which is node F, and working our way around the equation, we would around the circuit, we would first encounter the 24-volt source and the negative polarity of that 24-volt source. Then as we continue, we encounter R1, which has a 16-volt source, a 16-volt drop across it. We continue on to the next independent source, which is 12 volts. We encounter the negative voltage polarity across it first. On to R2, where we encounter a 4-volt drop. On to R3, we encounter a 6-volt drop. On to R4, which is a 10-volt drop. And then ultimately back to the point at which we began, and that's equal to 0. So that is our mesh equation for that circuit. So it's just a practice problem with some relation to Kirchhoff's voltage law that allows you to write that loop equation. But most importantly in this problem, we want to find VAE and VEC. When you see a voltage like VAE written as it's written, you think of it as VAE plus to minus. So we're going to find the voltage from node A to node E, with node A being positive voltage compared to relative to node D or node E. So first thing we do is we can draw that on our circuit if we want. This is what we're looking for, the voltage from A to E. It's called VAE. And so we designate that with an arrow, with the head of the arrow on the positive A node and the tail of the arrow on the negative E node. And we're looking for that voltage from one to the other. So we can do that by adding up the voltages in either direction around our mesh, just so we start at A and we end at E. So if we start at A and we go around the left side of the circuit down from A, working our way down, we end up adding a plus 24 volts for the independent source, and then we continue, we hit a negative 10 volt drop across resistor R4 before we get to E. So if we add those two together, we end up with a 14 volt drop VAE. We could have easily gone the other direction as well. So we could have found VAE by going, put OR out here in front, around the other way with the circuit. So we can start at A, go through R1 first, and we have 16 volt drop, and then after that we would encounter the 12 volt, the negative polarity of it first. Continuing around the loop, we would hit the plus 4 volts across resistor 2. Continuing around the loop, we would hit the plus 6 volts across resistor 3, and then we reach E. So if we add all those up, we end up with 14 volts. So either way would have gotten us the same answer. The second part of this problem is to find VEC. VEC is the drop from, plus or minus again, from E to C. So we can draw us an arrow, put an arrowhead at the E, that's VEC. So we're going to start at E, and we can go either direction, again, around the circuit to find the voltage drop. Let's take the direction where we take and go counterclockwise from E and reach up to C. If we do that, we first encounter a minus 6 volts across resistor 3, And then we have a minus 4 volts across resistor 2 before we reach node C. So starting at E, going counterclockwise till we reach node C. And that gives us a minus 10 volts for the voltage across EC. Similarly, we could have gone the other direction, and if we do that, we can find VC will come out to the same value. Starting at E, going to C, but this time clockwise, and looking at the voltage drop across R4 first, it's 10 volts. And then we go through the independent source, which is 24 volts. R1, which has a 16 volt drop across it, and the 12 volt source where we're hitting the negative polarity of that source first. And again, if we add those up, we would get minus 10 volts for VEC.